Alright, this video covers Module 5, Homework 1, which is talking about GCF and factor by grouping. So we're going to find the GCF, we're going to factor out the GCF, and then we're going to factor by grouping. So it says we're going to express a number as a product of factors. Remember, product means multiplying two factors together. So, for example, factors are numbers that you can multiply together to get itself. So, for example, factors of, let's say, 10. So we have 1 times 10 is 10. 2 times 5 is 10. Is 10. So those are examples of factors. So 1, 2, 5, and 10 are factors. So we can express it as a product of factors just like we did right here. So for GCF, GCF means our greatest common factor. So the largest factor that numbers have in common. So this example says to find the GCF, find the greatest common factor for 42, 24, and 54. So in order to do so, let's write out our list of factors for 42. So we have 1 times 42, 2 times 21, 3 and 14, 42 divided by 4 gives us a decimal, so I know that's not going to work. 5's not going to work. 6 times 7. 7's already on our list, so we know that our list is done. So moving on to 24. 1 times 24. 2 times 12. 3 times 8. 4 times 6. 5 doesn't go into 24. 6 is already there, so we know our list is done. Lastly, 54. 1 times 54. 2 times 27. 3 and 18. 4 doesn't work. 5 doesn't work. 6 and 9. 7 doesn't work. 8 doesn't work. 9 is already there, so we know our list is done. So now we're looking for the largest factor. What largest number here do they all have in common? Which would be 6. So we would know that our GCF is going to be 6 between 42, 24, and 54. Same thing for the next one, but now we have letters to play with. So we have 42a cubed b, 24a squared b squared, 54ab cubed. So if you notice, it's the same numbers again. So 42a cubed b, 24a squared b squared, and 54ab cubed. So we already know that 42, 24, and 54 all have a 6 in common from the previous problem. So we know that GCF is going to be 6 from the previous example. So now we're trying to see how many A's and B's they have in common. So let's go ahead and write this out. So the first one, we have 42a cubed b. So we have 3 A's and 1 B. 24a squared b squared. So A times A, B times B, and then 54a b cubed. So we have 3 B's there. So trying to see what they all have in common. So they all have the 6 in common from our previous example. They all have 1 A in common. This last one only has 1 A, so we can't have more than 1 A in common. And they all have 1 B in common. Likewise, this first one only has 1 B, so they can't have more than 1 B in common. So our GCF is 6AB. That's going to be our final answer. So if you notice, so we're trying to, in math, we're always trying to generalize it to kind of figure out what's going on here. So our 6 was from the previous example, and if you notice, they all have one A in common and they all have one B in common. So when looking for the GCF, you are looking for the smallest exponent. To tell you how many they have in common. We're looking for the smallest exponent to tell you how many they have in common. So there's only one A here and there's only one B here, so they can't have more than one A or more than one B in common. All right, so last example for this page. Factor out the greatest common factor from the following polynomial. 5y to the 4th minus 10xy to the 5th. So trying to find our GCF first. I know between 5 and 10, they both have a 5 in common. This first one doesn't have any x's, so they don't have any x's in common. We have 4y's here and 5y's here. So that's telling me they both have 4y's in common. So our GCF should be 5y to the 4th. So we're wanting to factor that out. Factoring means divide. So factoring something out is the same as dividing something out. Because whenever you put it back in, the opposite of factoring is distributing. Distributing is multiplication. So we can divide out our GCF or factor out our GCF of 5y to the 4th from both terms. So taking out that GCF of 5y to the 4th, we have to see what's left over. So 5y to the 4th divided by 5y to the 4th will give us 1. 5 divided by 5 is 1. We have 4y's. We're taking away 4y's, so no y's are left over. Negative 10 divided by 5 will give us negative 2. 1x is on top. We have 5y's. We're taking away 4y's, so we have 1y left over. Going back to our properties of exponents, remember we can subtract our exponents whenever dividing. So this is our final answer, 5y to the 4th times 1 minus 2xy. Remember, if we were to distribute that 5y to the 4th back in, we would get back to our original problem of 5y to the 4th minus 10xy to the 5th. So next page. So again, factoring out the GCF, we have 9x to the 7th minus 27x to the 6th plus 54x to the 5th. So trying to see what they all have in common. So looking at this, I notice they all have a 9 in common. This one has 7x's, 6x's, 5x's, so they all have at least 5x's in common. So 9x to the 5th is going to be our GCF. We are factoring it out. We're taking it out, so that means we're dividing it out from all of our terms. So looking at what's left over. So 9 divided by 9 is 1. We have 7x's up top. We're taking away 5x's. That means 2x's are left over. Negative 27 divided by 9 is negative 3. We have 6x's. We're taking away 5 of them, so we have 1x left over. Lastly, 54 divided by 9 will give us positive 6. We have 5x's. We're taking away 5x's, so no x's are left over. That's our final answer. Again, if we were to distribute 9x to the 5th back in, we get back to our original problem. So still factoring out GCF, the greatest common factor. We have 2 times x plus 8 plus a times x plus 8. So we're trying to see what do they all have in common. So I notice they both have this x plus 8 in common. So that's going to be our GCF. And whenever we factor or divide out the x plus 8 from both terms, x plus 8 divided by x plus 8 cancels out, and we're left with 2. Again, x plus 8 over x plus 8 cancels out. we're left over with plus a. So x plus 8 times 2 plus a is going to be our answer. So, GCF. The next question says factor the following polynomial by grouping. So our first step in factoring is factoring out the GCF. So we have AB plus 8A plus 2B plus 16. Looking to see what they all have in common. As of right now, they have nothing in common, so there's no GCF. So then it says factor by grouping. So it means I'm going to group these first two terms together and group the last two terms together to then see if they have a GCF. Notice this 2b is positive, so I want to group that positive plus sign with the 2b. So looking at our first two terms, AB plus 8A, we're trying to see what do they have in common. We notice they both have an A in common, so we can factor or divide out an A from both terms. Our A's will cancel, we're left over with B. Again, our A's are canceled, we're left over with plus 8. So now looking at our next two terms, we have 2b plus 16. So notice they both have a 2 in common, so I can factor out that GCF of 2. So whenever we factor or divide out that GCF of 2, we are left over with 2b divided by 2. Those 2's will cancel out. We're left over with b. 16 divided by 2 will leave us with a positive 8. So just like the previous problem, we have a times b plus 8 plus 2 times b plus 8. So both terms have that b plus 8 in common. So that's going to be our GCF again. So taking out our b plus 8, we're going to divide out that b plus 8 from both terms. That way those cancel, we are left over with a plus 2. So we have b plus 8 times a plus 2. That's our final answer. We just factored by grouping. B plus 8 is a factor, a plus 2 is a factor. Multiply those two factors together, we'll get back to our original problem. Last one for this page, factor the following polynomial by grouping. Again, we have 18xy minus 4x minus 9y plus 2. So looking at this right now for a GCF, I notice there's nothing that they all have in common. So no GCF. So now we can factor by grouping. We can group the first two together, group the last two together. Just like the previous problem, this 9y is negative, so make sure to keep that negative sign with the 9y. Looking at our first two terms, we have 18xy minus 4x. So I notice they both have a 2x in common. So we are going to factor or divide out 2x from both terms. 18 divided by 2 will leave us with 9. X divided by x will cancel each other out. That y is going to stay there. Negative 4 divided by 2 is negative 2. And again, those x's cancel out. So we're left over with 9y minus 2. Just like the previous problem, when these two are the same, they can come outside as a GCF. So if I have 9y minus 2, I know I want 9y minus 2 to be left over for my other factor. So if I have negative 9y plus 2, as of right now there's nothing that they have in common, but I want to make it look like positive 9y minus 2. So I can factor out a negative 1 from both terms. I have to factor out something. So they always have a 1 in common. I want to factor out that negative. So now that I'm left over with negative 9 divided by negative 1 is positive 9y. Positive 2 divided by negative 1 is negative 2. So now we're left over with 2x times 9y minus 2 minus 1 times 9y minus 2. I know we did it right because they are both 9y minus 2. They have that in common. Taking out that GCF of 9y minus 2, we are left over with our other factor of 2x minus 1. So these are our two factors. 9y minus 2 is one factor. 2x minus 1 is another factor. Multiply those two factors together, you'll get back to your original problem. So next page. So factor the following polynomial. We have negative 10x to the 8th y plus 15x y to the 9th. So looking at this, I know they both have a 5 in common. I have 8x's here, 1x here, so they have at least 1x in common. 1y here, 9y's here, so they have at least 1y in common. So that's going to be our GCF. Taking out that 5xy, we have negative 10 divided by 5 is negative 2. 8x's, we're taking away 1x, so we have 7x's left over. 1y, we're taking away 1y, so those cancel each other out. Plus 15 divided by 5 will give us 3. We have 1x, we're taking away 1x, so those cancel each other out. We have 9y's, we're taking away 1y, so we have 8y's left over. So we have 5xy times negative 2x to the 7th plus 3y to the 8th. 5xy is one factor, negative 2x to the 7th plus 3y to the 8th is another factor. Multiply those two factors together, we'll get back to our original problem. The next example says factor the following polynomial. We have xy plus 2y minus 9x minus 18. Our first step in factoring is GCF. There's nothing that all four terms have in common, so no GCF. I notice there's 4 terms we can now factor by grouping. So we can group the first 2 terms together, group the last 2 terms together. Again, remember this negative goes with the 9x, so we're going to leave those 2 together. So looking at our first 2 terms, xy plus 2y, I notice they both have a y in common, so we're going to factor that GCF out. That way they cancel, cancel. We are left over with x plus 2. Looking at our next 2 terms, remember we know we want x plus 2 to be left over. We have negative 9x minus 18. They both have a negative 9 in common, so let's factor that out. Factoring out negative 9, we are left over with x plus 2. Negative 9x divided by negative 9 is going to leave us with 1x. Negative 18 divided by negative 9 will leave us with positive 2. So now we have y times x plus 2 minus 9 times x plus 2. So we know we did something right because they both have an x plus 2 in common. Taking out that x plus 2, we are left over with y minus 9. So this is our answer. X plus 2 is one factor, y minus 9 is another factor. Multiply those 2 factors together and we'll get back to our original problem. So last example for this notes section. So factor the following polynomial. 6x squared minus 2x minus 2. So our first step in factoring is look for a GCF. I notice they all have a 2 in common. So we can factor out that GCF of 2. We are left over with 6x squared divided by 2 will leave us with 3x squared. Negative 2x divided by 2 will leave us with negative 1x. Negative 2 divided by positive 2 is negative 1. There's only 3 terms here, so we cannot factor by grouping. So we are done. So 2 is one factor, 3x squared minus x minus 1 is another factor. Multiply our 2 factors together to get back to our original problem. So bringing it all together, let's conclude. So standard form is going to be our ax squared plus bx plus c, where a, b, and c are real numbers. So just in general, just multiply it all out. Our factored form, we're going to have some number times x plus another number times some number times x plus another number. So basically it's just saying we have factor times a factor multiplied together to give us back to our standard form. So these two things are the same expressions. They're just written in two different forms. So just written in different ways. Same thing, just written in different ways. What operation is factoring? Adding, subtracting, multiplying, or dividing. Factoring is taking it out. We're going to be dividing. The opposite of factoring is to distribute it back in. Distributing is multiplication. And then our biggest takeaway, remember, no matter what, our first step is to look for a GCF. Look for a GCF first. So that is Module 5, Homework 1 notes.